Okay, so complete the proof. When you do a proof, you are doing what? What matters? What are we looking for? What are some key things that will show up with every proof you do? Given. That should be your starting point, right? What is given, okay? So in this one, you are given these two things. I'm not going to write them down. Just put an arrow and call it given, okay? What else do you know with every proof you do? Whatever they asked you to prove goes where? The last step, okay? So you would say triangle EGF is congruent to triangle HFG, okay? So we know that every single time. Whatever they asked you to prove is your last thing. The rest is up to you. How do we get there? On this one, it's reflexive. So always look at the stuff they gave you. E is congruent to H. These two angles are also congruent. So you currently have two angles congruent to two angles. How many things do you need to be able to prove triangles congruent? You need 3 sets of congruent things, right? So if we have 2, we're just missing one piece. What's the one piece we're missing? The side, right? This side is reflexive. So we can say GF is congruent to GF because of the reflexive property. So why are those triangles congruent? AAS. Why not ASA? Because there's 2 angles and a side. It's not included, right? It's not the one in between. So angle, angle. This is the non-included side, okay? Not the one in between. The included would be that one, and we don't know that one. So this is AAS. Questions on that? Are we starting to feel a little bit better about proofs yet? Anyone like proofs yet? I love them. I love them. Okay, yeah.
What are the 4 letters combinations that we've done?
We have done so far SSS, SAS, ASA, and AAS. So those ones we've done. I will eventually teach you HL also, but we're not there yet. That comes, I think, in 4-6. But yeah, these are the only ones that work. Anything else does not exist. Donkey doesn't exist, right? Okay. This one says, given that K is congruent to M and KL is congruent to ML, prove these triangles congruent. Okay. Where do you start? The given. We know all of this information because it was given to us. We also know that whatever they asked us to prove goes here. Triangle JKL will be congruent to triangle PML. We just have to prove why they are congruent. Take a look at your picture. Okay, look at the information they gave you and then see, is there any other information I know? I need 3 sides or 2 angles and a side or 2 sides and an angle. I currently have an angle and a side. Okay, so there should be some things that you're like, well, I know it's not donkey. It's not ASS, so I know it's not this side with this side. That would be donkey. It could be this side with this side because SAS does exist, but do I know MP is congruent to JK? No. What do I know in this picture? The angles. This angle and this angle are what kind of angles? Vertical angles. So we can say angle MLP is congruent to angle JLK because of vertical angles. Okay. And this is why I say mark everything that you know as you go, because when you mark it, then you can see, oh, here's another angle with another angle. What triangle congruence postulate does that get us? ASA. It's the included side, right? Angle, side, angle. A reminder, I said this to you yesterday. I think I said it the day before that too. If the step is a triangle congruent to a triangle, then the reason is always going to be one of those 3-letter postulates that we've done. SSS, SAS, ASA, or AAS. Okay? Okay. Take a look at this one. Here's your given information, and they've marked it. These lines are parallel. Those segments are congruent. So that's your given. We take what they asked us to prove, and we put it in that last slot. Tell me what you know. Aiden. ZX is congruent to ZX, okay? ZX is congruent to ZX. And why is that? That's reflexive. By the way, a lot of you on your quiz wrote reflective. This is an X, right? Not a CT, reflexive. Okay, so we know 2 things. We know 2 sides. So it's either going to be a third side or it's going to be the included angle, right? SAS or SSS with 2 sides. Yes. Yeah. It's AIA. Okay, the reason is AIA. Where you have to be a little bit careful is how you name it. Which angles are we talking about for AIA? YZX and WXZ, right? Here's your parallel lines. Here's your transversal. When you make that Z, it's that inside parts of that Z. So angle YZX is congruent to angle WXZ by AIA. Okay, now look at your markings. And remember, mark them as you go. The more you mark, the better your chance of figuring out which triangle congruence theorem we have. What is this? Side angle side. But I'm glad you did that because a lot of people on this problem say ASA because you just see the alternating letters, right? You go, oh, there's one, a different one, and then back to the one. I would mark them so that you make sure you have the right letter because ASA is not this, right? This is SAS. So just be careful with that when you're naming it. I see that a lot. A lot of people mix up just what A and S stands for. A stands for what? Angle. S stands for side. So make sure you're talking about angles and sides. All right. Last proof here. You're given this information, okay? And that's all marked for you. Remember, if it is marked, it is given, okay? So your markings are your given. What they asked you to prove goes in that last spot. How are we going to get there? What do you see in this picture? What else do we know? Vertical angles, yes. So mark them, okay? And then you can name them. Angle BCA is congruent to angle DCE because of vertical angles. Okay. So knowing that, we can now say the triangles are congruent. Why? Side, angle, side with side, angle, side, right? So that is SAS. Yeah, Byron.
When you're proving it, would you get it wrong if you like switched the A and B? So instead of BCA, you have ACB.
No, that's fine. When it's an angle, it doesn't matter because you're just saying my vertex is C and my vertex is C, right? It's when it's the triangles, then it matters if you switch the other two. Yeah, that's a good question. Questions on that? Okay, let's take a look at this. Which postulate or theorem would you use if there's not enough info? Say not enough info. So look at number 5 here. What would that be? SAS. Now, did they mark the angles congruent? Not congruent, right? They didn't put the arcs there. But what does this mean? What is the box? Right triangles, right angles. And all right angles are congruent. So we know they're congruent, even though they're not the arc. They're still 90 and 90. So side, angle, side, with side, angle, side. So we would say, now here's where you have to be careful. Triangle, if I say A, B, C, what triangle is that congruent to? Not FED. I started at A. I went to B and then to C. So I need to go D to E to F. Okay, by, side, angle, side. All right, number 6, are those congruent?
Yeah.
Why? Not third angles theorem. Because we don't know any of the angles here. Side, side, side. This is reflexive, right? Even though reflexive's not marked, we know it. So you may mark it, okay? So I would say, and now here again, be careful. How are you going to name this? If I say, I would go OMK. Okay, so through the first marking, through the double marking. So go through the first marking, through the double marking. That would be which triangle? KLO. By SSS. Side, side, side. We don't know any angles there. If the lines were marked parallel, then we would know some of the angles, right? But they're not, so you can't assume it. You got to go based on what we know. Okay, look at 7 here. Are those congruent?
No,
Why not?
because we don't know that ZY is the angle bisector.
Okay, so we don't know these angles are congruent. It kind of looks like they are, but we can't mark them congruent. Is there anything you do know in this setup?
ZY is reflexive.
You know ZY, okay? What do you see when you mark ZY? Not SAS. ASS. This is donkey, right? You don't swear at your teacher. Don't do it. Therefore, not enough info, right? If it shows up as donkey, they might be congruent, but we don't know, okay? Now, if it had given us this, then it would be SAS, right? But we don't know that. Where are we at? Okay, number 8 here. Are those two triangles congruent?
Yeah.
Why? The vertical angles. Okay, so we know this congruent to that, which means what? SAS. That's the included angle. Okay, so this isn't donkey, even though there's two sides and an angle. It's the one in between. So we would say, someone want to try to give me the two triangles? PTF. Okay, so if we go triangle PTF, it would be congruent to GTS. By side, angle, side. So side with side, included angle with included angle, side with side. Okay, so take your time naming them because that's where a lot of like the silly mistakes show up. Match up the corresponding parts, okay? How about this one? Number 9. ASA. Let's name it. If I say triangle RQS, what triangle is that congruent to? TUV. Okay, so I went single arc, double arc, no arc. So I need to go single arc, double arc, no arc. Okay, by angle, side, angle. Does everyone understand, oops, why this is not AAS? Are you all getting that concept? AAS cannot have the side in between the two angles, right? AAS would be if you had that one, or if you had this one, that would be AAS. But because you have the one in between, it's ASA, okay? All right, how about number 10? That one is AAS. You have vertical angles, so mark what you know. This is the included side, which means this is non-included side. So you would say triangle, if I say PQT, which triangle is that congruent to? So PQT is no arc, double arc, single arc, RQS. By angle, angle, side. So you don't have the included, so it's not ASA. It's got to be AAS. All right, last one here. This one says triangle FGH and triangle PQR are both equilateral triangles. Your friend says this means they are congruent by the SSS postulate. Is your friend correct? FGH and PQR are equilateral triangles. Are they congruent by SSS?
Yes.
Why do you think so?
Because they're equal, right? They're equal.
What are equal?
The triangle. So that means like if FG has to be congruent to PQ. And,
Does it?
or
Let's say this is FGH and it is an equilateral triangle. Is that the only equilateral triangle that exists? Ooh. Squiggly line. This is also an equilateral triangle. Maybe this is PQR. It says FGH and PQR are both equilateral triangles. Are those both equilateral triangles?
yes.
Yes. Are they congruent to each other? You can't use SSS here. SSS has to be that this side is congruent to that side, right? And it's not. So it's tempting to say SSS because you're like, well, yeah, all three of those are the same. And then all three of these are the same, but they're not the same triangle. Why are they not the same triangle? Are their angles the same? Their angles are the same, right? In an equilateral triangle, all 6 of these are going to be the same measure. Do you know what measure?
60?
60, right? 180 divided by 3. This is 60, 60, and 60. This is 60, 60, and 60. This right here is why there is no AAA postulate. It doesn't exist because I can have 2 triangles that are AAA, right? This angle is congruent to this angle, and this angle is congruent to that angle, and that angle is congruent to that angle, but those are obviously not the same triangle, right? So is your friend correct? No. They still have different side lengths, even though their angles are the same. They can have different lengths and still be both equilateral. Does that make sense? Okay, I'm done. Your homework for tonight is 4.3b, so a few more proofs for you to try out, right? Hopefully at this point, this is starting to feel a little more normal, a little more like, oh, I know what I'm looking for. I know what's missing. I know what I have to find. If you are still like totally in the dark on these proofs, that's okay, but I need you to reach out to me because I can't tell just by looking at you if you're there or not, okay? So if you are struggling on this, I'm happy to sit down with you. I would love to sit down with you. It's the best part of my job, okay? So don't be bashful.